Okay, in this video I'm going to work through some of our examples from our exponent handout. So for instance, the second one on this handout, we need to just use one of our properties that says if we have a couple things multiplied together, raised to a power, we're going to raise each factor to that power. So we got to take 8 and square it, take x cubed and square it. Now for the 8 part, we're going to just square the number to get 64. For the x cubed, we're going to use a property of exponents, which says a base raised to a power raised to a further power. Lets us to keep the base and multiply the exponents together. Okay, similar for this next example, we're going to distribute the exponent to each factor. We're going to square -3, square x squared, square y to the 5th. For the numerical part, we can just plainly evaluate. -3 squared is 9. Multiply the exponents for the remaining factors to get x to the 4th times y to the 10th. For the one below it, we'll use the definition for negative exponent, which is that we're going to take that expression and put 1 over that expression to the positive third power. Then we're going to distribute the third exponent to each factor. So we're going to get 10 cubed times x squared cubed, and then evaluate. 10 cubed is 1,000. Again, we're going to multiply the exponents to get x to the 6th power. Okay, moving down a couple. Again, let's work with one with negative exponents. That negative second exponent there is going to tell us to do 1 over that expression, 5x cubed over y, to the positive second power, and then distribute that exponent 2 to each factor in top and bottom of the fraction in the denominator. So we're going to square the 5, the x cubed, and the y. Then simplify it. We get 25. We get 1 over 25x to the 6th over y squared. Now we're going to use our definition for dividing by a fraction. We've got 1 divided by this fraction. We're going to multiply 1 therefore by the reciprocal, which just gives us y squared over 25x to the 6th power. For the one below that, again, we're going to work with the numerical parts and the variable parts separately. So we're going to divide the 5 into top and bottom to simplify, leaving us with -3 on top. Cancel 4 a's from the top and the bottom, leaving us with 6 on the bottom. We can't do that cancelization necessarily with the negative exponent, so we got to reciprocate that or move it to the numerator, make it b to the positive third power over a to the 6th, and then we just combine to give us -3b to the 5th, add the exponents, and then over a to the 6th power. Okay, last one we're going to do is the last example from this group. So we're going to start on the inside, distribute the -4 exponent through, distribute the -3 exponent through those parentheses. And that means we're going to raise each factor, to that power. Now, got a typo here. This is supposed to be not x to the 4th. It's going to be x to the -8th when we multiply our exponents. Likewise, it's going to be y to the -5 times -4, which is the 20th power. On the bottom, we get x to the -15th, 5 times -3, y to the positive 6th squared. Then we're going to simplify by rewriting these negative exponents. We're going to move the x to the -15th up, the x to the -8th at the bottom, make the exponents positive. So that gives us x to the 15th times y to the 20th. That's supposed to be a y to the 20th, not an x to the 20th, over x to the 8th over y to the 6th power. Now simplifying, we get x to the 15th over x to the 8th, which is x to the 7th, times 20 y's over 6 y's gives us 14. And then we get x to the 14th times y to the 28th power. Okay. Okay, in the next part of the video, we're going to work through the bottom half of the sheet, which is rewriting various bases and combinations of bases to various powers. You notice, though, that the numbers in this part are very large. We got 9 to the 3,000th power. If you try to compute that with a calculator, it won't do it. It'll give you an overflow error. It's a huge, huge number. So you really do have to know the concepts. You got to know the properties of exponents to work these problems through. So let's take a look at the first one. I'm going to do a few of these. So we get 9 to the 3,000ths. We want to write that as a power of 3. You're going to keep your 3,000th power and try to write the base 9 as a power of 3. And we can. It's 3 squared. And then we're going to multiply the exponents to get 3 to the 6,000th power. Skipping down a couple, we want to write 5 to the 4,000 as a power of 25. A little more difficult here. Got to increase your exponent, so you want to write the 4,000. That's as a typo. It should be 4 or 2 times 2,000 here, and then we're going to pull the 2,000 exponent off, and then you get 25 to the 2,000th power. Okay, moving down a little bit, we want to write 2 to the 5th times 8 to the 1,000th as a power of 2. You already have 2 to the 5th as a power of 2. The idea is to write the 8 to the 1,000th as a power of 2. We can do that because 2 or 8 is 2 cubed. Now multiply the exponents to get 3,000 there. And now we got the same base. We're multiplying. We're going to add our exponents to get 3,005. Okay. All right. Now move down and work out another one. So at the bottom here, but again, we're seeing a lot of times the idea is going to be the same. We're going to have to write one of the factors somewhere as a power of what we want it to achieve, and then we're going to use our exponent properties. All right, so let's do this last one, or second to last one. We want to write this combination 8 over 2,000, 8 to the 1,000 over 2 to the 5th as a power of 2. So we're first going to write the numerator as 2 to the 3rd raised to the thousandths to make it a power of 2. We can't cancel yet until we do that, or can't use any other exponent properties until we do that. So now we're going to get 2 to the 3,000th on top over 2 to the 5th. Now we can just keep our base, right? We got dividing with the same base. We can keep the base and subtract the exponents to give us 2 raised to the 2,995th power.